All right, let's talk about one of the most common questions and hurdles in Kubernetes. You spent all this time building an awesome application, but now, how do you actually get people to see it? We're going to walk through that entire journey, from your local machine all the way to a live deployment.
So you've done all the hard work, right? You've containerized your app, you've written the YAML, your pods are up and running perfectly inside the cluster. But there's a catch. By default, nobody outside of that cluster can get to it. So how do we actually open the doors?
I love this analogy. Think of your app as a perfectly crafted ship, sailing beautifully, but it's inside a sealed glass bottle. It's completely cut off from the outside world. Our job is to figure out the right way to get that ship out of the bottle and onto the open sea where everyone can see it. First, let's start with the tools every developer needs in their pocket. These are the go-to methods for the day-to-day grind. Debugging your code, doing quick tests, and showing off what you've built before it's really ready for prime time.
First up is the most direct, the most personal tool we have, port forwarding. Think of this as your own private peephole into a pod that's running deep inside the cluster. This isn't for users, it's not even for your teammates to see a demo. This one is just for you.
And the best part? It's just one simple command. You run kubectl port forward, and bam! It creates this secure tunnel right from your laptop straight to a specific pod. It's absolutely perfect for when you need to poke around a microservice and figure out what's going on without anyone else even knowing it's there.
Okay, so what if you need to show your work to someone else? Like you want to quickly show a colleague a new feature you've been working on. You need something a little more accessible than port forwarding, but it's definitely not ready for the public yet. Well, that's where NodePort comes into play. So a NodePort service works by blasting open the same high-numbered port on every single node in your cluster. This makes your app reachable for quick tests or those internal demos. And let me be super clear about this, NodePort is not something you want to use in production. It's just clunky, you have to deal with these weird high port numbers, you don't get real load balancing, and frankly, opening ports on all your nodes can be a bit of a security nightmare. So let's trace the path of the traffic here. A user hits the IP address of any of your nodes on that specific high port. That node then passes the traffic along to the internal Kubernetes service, and the service finally figures out which pod should get it. It works, for sure, but it's not exactly what you'd call elegant. Okay, enough playing around. Our app is debugged, it's been demoed, and now it's time to go live. We need solutions that are robust, that can scale, and that are really designed to handle real users and production-level traffic. This is where it gets serious. Now we're getting into the real deal. Our first production grid tool is the LoadBalancer service type. If you're running your cluster on a big cloud provider, think AWS, GCP, Azure, this is usually the most direct, most reliable way to get your app out there. And here's where the magic happens, automation. When you create a service and set the type to LoadBalancer, Kubernetes just takes care of it. It talks to your cloud provider's API and automatically spins up a real, dedicated, public-facing load balancer for you. This gives you a stable public IP address, and you barely had to lift a finger outside of Kubernetes. The traffic flow here is just super clean, very professional. Your users hit the public IP of that shiny new cloud load balancer. It then intelligently spreads the traffic out to your Kubernetes service, which then distributes it to your healthy pods. It's simple, it's solid, and it's absolutely built for production. But what happens when things get more complicated? What if you're running multiple services? Or what if you need to send traffic to different services based on the URL, like api.example.com goes here and blog.example.com goes there? For that kind of fine-grained control, we need the most powerful tool in the box, Ingress. Now, this is a really important point to get. An Ingress resource by itself does nothing. It's just a set of rules, like a configuration file. To actually make it work, you need another piece of software running in your cluster called an Ingress controller. Things like Nginx or Traffic are super popular. That controller is the smart traffic cop at the front door of your cluster, reading your Ingress rules and directing traffic exactly where it needs to go. So this brings us to probably the biggest decision you'll make when going to production. Load Balancer is all about simplicity. One service, one public IP. It's easy, but man, it can get expensive if you have a lot of services. Ingress, on the other hand, is all about flexibility and saving money. You can have dozens of services all sharing one single entry point. It's that smart Layer 7 router that can handle different domain names and even manage your SSL certificates. For most complex apps, Ingress is the way to go. Okay, so right now you might be thinking,
That's all great for people running in the cloud, but what about me? I'm running Kubernetes on my own servers in my own data center. Well, you're right, that load balancer service type won't work out of the box for you. But don't worry, there is a fantastic solution. Say hello to MetalLB. This is an awesome open source project that basically brings that cloud-style load balancer functionality right into your on-premise bare metal clusters. It's designed to fill that exact gap that's left when you don't have a cloud provider to help you out. Its whole purpose is just so straightforward. You install MetalLB into your cluster, and from that moment on, whenever you create a service of type load balancer, your cluster knows what to do. MetalLB steps in and handles it, giving you that simple, easy, cloud-like experience right in your own data center. Wow, okay, we have covered a ton of ground, huh? We've gone from these quick developer hacks all the way to some really robust production-grade solutions. So let's bring it all home and boil it down to one final, super clear blueprint you can use to make the right call every time. Okay, you might want to screenshot this slide, because this is the ultimate cheat sheet. In the cloud and you want simple and reliable? Use a load balancer. Need power, flexibility, routing, and a way to save some money? Ingress is your absolute best friend. NodePort? That's just for quick demos. Port forwarding? That's for your eyes only. And MetalLB? That's your ticket if you're running on bare metal. This is it. This is the blueprint.